And so the electrons, if they can be by themselves, they will be. So for example, these guys, this two, they are sharing when they don't have to because there's an empty orbital. And whereas in this one you can see only only two arrows are sharing a box, and the rest of the arrows have their own boxes. And then last but not least, we have Pauli's exclusion principle. And this is where it says no more than two electrons, and then they must have opposite spins. So you can't have two arrows facing the same direction. One is going to have to go up and the other is going to have to go into setting up our orbital diagrams and actually drawing them. So our first element that we're going to talk about is oxygen. And oxygen has 8 electrons. So I'm going to show you exactly how you draw this. So we're just going to fill in. First things first, we want to make sure that our arrows, if they're in the same box, we have one going up, one going down. We want to make sure we don't skip any orbitals. And then we want to make sure that when we get to our 2p, that we don't pair them until they're all filled. So what that looks like, so we're going to count. 1 going up, 2 going down, 3 going up, 2 going down, and then we move on to 2p. And if you notice, 2p, all of our s orbitals only had one box, but our p orbital has 3 boxes. So what we're going to do is we're going to put one arrow in each box before we pair it. So let's go over that again. When I filled up my P, I did one up arrow in the first one up arrow in the second one, and one up arrow in the third one before I made my 4th arrow. So this ends up being 8. 2, 4, 6, 8. That's my 8 electrons for oxygen. Okay. Then I have my phosphorus. Okay. So my phosphorus, same thing. I have 15 electrons, and so I'm going to follow the 3 rules that we just went over, and I'm just going to put them in. So we have 1, 2, 3, 4, 5, 6, 7. Notice I did all up arrows first before I started pairing them. 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, again, I did all up arrows. I filled up all of my spaces here before I started pairing them, and there's my 15 electrons. Okay, so now you have chlorine, and you are going to fill out chlorine by yourself. I'm going to give you a little bit of time. Okay, so chlorine is very similar to what we've been doing. You go through, you do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And notice again, when I filled up my box, my orbital that has more than my sublevel that has more than one orbital in it, I put one arrow in each before I paired them. Okay? Now, if we were to be going backwards from our orbital diagram to our element, what you would do is you would count the number of arrows. Remember, each arrow represents an electron, and for this unit, our electrons are going to match our atomic numbers. So going back from orbital diagrams is super easy. Count your arrows. Okay, then you have iron, and I'm going to give you some time to go and look at iron. You should be doing this by yourself. So iron, skip this. Okay, so now guys, we're working on our Lewis dot structures. So in our Lewis dot structures, they're super simple. The number of dots is based on the row that it's in. This is very hard to see because it's pretty small, but if you notice at the top, There's a 1, 2, 3, 4, 5, 6, 7, 8, all the way to 18. And then at the bottom, they have these numbers in Roman numerals, and they have an A next to it. Okay? Those are the numbers that you're looking at, but just as a review, let's go over them. The very first row is going to have 1 dot. Okay? Then our second row is going to have 2 dots. Our third row is, and then all of these guys in the middle, we don't even pay attention to them. So I'm just going to cross these off because we're not even going to look at these guys. They're not even in our radar right now, okay? Then this is our third row. So this is 3A. We're going to have 3 dots, 4 dots, 5 dots, 6 dots, 7 dots, 8 dots. Okay? So we're going to get started with our first one, which is BA. Okay? So we have BA, and you go through and you're like, okay, BA is in my first, second, third row. So when I'm in my third row, I'm going to have 3 dots. One thing that I've noticed with a lot of my kids is they want to come, let me make this dot a little bit bigger. So one thing I've noticed is they want to do 1, 2, 3. Okay, that doesn't work. We have a very specific way of doing this. When you're filling these, it's kind of like the orbital diagrams we just went over. There's 4 places you can put dots. You can put dots at the top, you can put dots on the sides, and you can put a dot on the bottom. So when you're doing this, you can start wherever you'd like. But you have to make sure that you fill up all the sides first, all 4 sides, before you pair them. So we're going to do 1, 2, 3 for my B. Okay. Then we're going to go to our bromine. And our bromine is on row 1, 2, 3, 4, 5, 6, 7. There's my bromine right there. Ooh, can't really see it, but now we have 7. So now I'm going to count to 7. So I have 1, 2, 3, 4, 5, 6, 7. And as you can see, I went around and filled up all of my sides before I paired them. Okay. Now I have arsenic. Arsenic I'm going to count 1, 2, 3, 4, 5. Arsenic is in the 5th row, so I'm going to start here. 1, 2, 3, 4, 5. Okay. And now they have TL, and that one you're going to be able to do by yourself. Okay. So now we're moving on to our pre-AP. Okay. So if you're level, you're done. Good luck on your retest. You're going to do awesome. Okay, so now we're going to move on to seeing excited state in an electron configuration. Okay, so when you see excited state in an electron configuration, you're going to notice this normal electron configuration would be 1s2, 2s2, 2p6, and then this would be 3s. Instead of this being a 1, this would be a 2. Okay, and so what that looks like, and the reason why it's a 1 is because the other electron from this sublevel moved to our P. So now, instead, this was 4p, but now it's 5p because the electron from here moved up. Okay, if you're ever having to figure out the number of the elements, what element you have with an excited state electron configuration, all you do is you go in and you add up all of these numbers at the top. And this is the same thing. You go 1s2, 2s2, 2p6, 3s2, and then it's 3p5 when it should be 3p6. If you see that, then you should think, oh, okay, this is an excited state electron configuration. Okay, so here's a really good example of that. So whenever you're figuring out, it says, of the following electron configurations, identify which are excited and the element they represent. So this first one is excited. We go and we're like, okay, so we have 1s2 and then we have 2s1. So we can assume that this electron was bumped up to 2p. The electron from 2s was bumped up to 2p. So how I figured out what element it was I took these numbers at the top and I added them up. So it's 2 plus 1 plus 6 gives us 9, which is fluorine. Okay, and then you'd go through here and you'd see if all, and then you'd go see if they are excited by looking and seeing if the numbers don't add up like they're supposed to. And then once you see if they're excited, if they are excited, all you do is add up your numbers at the top. Okay, guys, y'all are awesome and amazing, and good luck on your test.